Hey guys, we are today on part 3.1, the density attribute. So we're gonna have a look at how we can start setting up the scattering of the main crystals. Alright, we're gonna create a context that we're gonna call rock attribute and dive inside. Let's grab an object merge so that we can bring the rock base that we created. Let's be careful and not take the high-res version. We just wanna work on the lower res version. I'm gonna isolate the context so that we don't see the other guys we created. So let's drop a point VOP. We're gonna call that point VOP normal density. So we're gonna create an attribute based on the normals of the object. So as you can see, they are all pointing into the normal direction. And what we can, but as soon as we plug the normal into a dot product, let's see, we got some interesting things going on. I'd rather plug that into the color for visualization purposes. And well, the dot product is basically isolating the normal on one axis. So that's pretty radical, and that would allow us to grow the crystal on the top faces of the rock. So that's pretty cool. So I'm adding a trigonometric function with our cosine so that we get all the slopes and details of the geometry. And since Houdini is working in radians, we're gonna convert that into degrees. So my slope are now into degrees, and we need to refit that so that we can visualize properly. Of course, the source max of the slope would be 180 degrees. And as soon as we plug a ramp parameter, we're gonna rename that guy ramp normal, like so. And let's play a bit with this ramp. First, the color are inverted. We want the Y to be on top, like so. So we're gonna fine tune a bit this ramp so that we conserve some of the slope detail that we have in our geometry. Something more like that, I guess. That could work. So I'm diving back inside, and right now this is a color attribute, and we're gonna convert that into a float and grab one of the outputs and plug that into a bind export. And the name of the attribute is gonna be, let's say, normal. It could be whatever you want, doesn't really matter. If you wanna call it top or dust or whatever, it's up to you. So in attribute wrangle, we're gonna create another attribute that we're gonna call density, and it's gonna be equal to, for now, at normal, and we declare the density as a float, so there is no confusion for the vex. And if we drop a scatter, we can basically scatter some particles, and we can use the density attribute we just created, and now it's spreading the particle just on the normal attribute that we created. So that's pretty cool. It's gonna be pretty handy to grow the crystals. One thing though is that we're gonna create some more attributes. So let's go back inside the rock base, and we wanna go back to that node. And this mountain node, we want to export all the basic shape that we had. And so I'm dropping a null that I'm calling output base shape, let's say. Right? So when we come back here, let's organize a bit with some color. We can make an object merge, and we're going to grab the output base shape that we just created. Let's poly extrude this little guy and increase the distance. Well, it's going into the normal direction. I'd rather use the transform extrude front and set that to global, and just increase the translate Y so that it's going straight up. And let's add a bit of divisions too. And we're gonna uncheck the output front. We don't need the cap of the geometry. So basically, we're gonna use this shape to transfer some color onto the rock. So we're gonna first center this geometry. Let's try with a transform, and decrease the translate Y. I'm gonna create a color attribute. Let's make some room, like so, and let's copy it onto our base shape. And this one actually is gonna be black, like that. Now the fun part, if we add an attribute transfer and plug the first input to the dark object and the second on the white one, we're gonna basically transfer the color. So I'm decreasing the distance threshold and increasing the blend width to get some kind of fall off. So we don't have enough division. I'm just gonna increase the number of subdivision like so, and maybe reduce the number of division into the extrude so that got some kind of square faces everywhere. Alright, actually I'd rather use a match size instead of the transform so that we can properly align this geometry with the rock. So everything is matching pretty well. If we increase the blend width, we actually got a nice fall off on the borders. Alright, let's decrease that, and we're gonna select this bunch of nodes and group that into a subnetwork. We're gonna call it something like border attributes. And let's edit the parameters. So we don't need these inputs. Let's make it invisible and dive inside. So we're gonna grab the blend width and drag and drop it inside the parameters. So from here, we could create a string parameter. We're gonna call it attribute name. Press OK. And now, if we drop an attribute triangle, so we're gonna convert the color attribute into a custom attribute. So let's say we're gonna call this attribute test. It's gonna be equal to cd.air. So let's not forget this little sign. And now we have a test attribute that's been created. Let's copy the parameter of the attribute name and pass relative reference inside the attribute triangle. So it looks like when you try to do that, it's actually clearing the whole code that you insert. So let's go back and pass that. Okay, so now what's going on is that if we try to change the attribute name to something else, let's say border, we have the attribute name that's got updated. So that's pretty handy. Most likely we'll reuse this little subnetwork to generate different attributes. So for now, we are going to use these border attributes to feed into the density of the crystals. So let's plug the border attribute into the attribute triangle. And what we want to do is basically, let's check out the scatter for the final density. Let's try to multiply at normal by at border. So, I did a typo. Let's put that at the end. Now we actually have the borders multiplied by the normal. And if we try to reverse the border with 1 minus at border, we have this nice fall off that if we play a bit more with the subnetwork we created with the blend width, we see how it's affecting the scattering of these particles, and it's getting more spread across the surface. So that will help a lot, giving some breakups and interesting things with the scattering. So I'm adding add cd equal add density so that we can visualize the density just on the geometry. So that will help getting some settings right. So let's actually visualize how it looks with the crystals. I'm dropping a copy stamp, and on the other side we'll have a file pointing to the crystal geometry that we created, crystal A. So that would be the guy, and let's plug that on the first input of the copy. So right now the scale is way too big. Let's unplug. So let's uncheck transform accumulative and reduce uniform scale to 0.1, something like that. Can reduce the number of particles to like hundreds. All right, that's what we got. Let's make sure in the stamp that we are using pack geometry before copying so that we optimize the whole thing. And next time we'll see how we can use attributes to drive the scale and the rotation.